Okay, today we are going to see one geometry problem which appears in the IMO 2006, which is placed in problem 1. It is relatively a simple problem. So let ABC be a triangle with in the center I. A point P in the interior of the triangle satisfies angle PBA plus angle PCA. Let me mark these angles: PBA, PCA, PBC plus PCB. Use the circle. So we should show that AP is larger or equal to AI, and that equality holds if and only if P equals to I. So how can we do this? When we see this kind of model, let me show you. This kind of model, what will we think if I mark these angles? There is a very obvious conclusion, that is angle 4 equals to the sum of the rest angles, angle 1 plus angle 2 plus angle 3. The proof of this conclusion is very easy, so I will not show it here. So back to the problem. We know that angle BPC equals to angle BAC plus angle PBA plus angle PBC. PCA equals to angle BAC plus angle PBC plus angle PCB. Why do I write this? Because here the sum of the angles in the brackets are the same according to what we have in the problem. And also we have angle BPC equals to 180 degrees minus the sum of angle PBC and angle PCB. So if we connect these two, we can have angle PBC plus angle PCB equals to half of 180 degrees minus angle A. I will just use A instead of angle BAC. So it equals to 90 degrees minus half of angle A. Right? So we can know that the angle BPC equals to 180 degrees minus bracket 90 degrees minus half of angle A. So it is 90 degrees plus half of angle A. So after knowing this, what can we have after that? Notice that I is in the center of the triangle. So angle BIC also equals to 90 degrees plus half of angle A. From these two, we know that BP, BC, IP are concyclic. Right? So after that, what is the circumcenter of the triangle BIC? So after knowing this, after knowing BCIP are concyclic, we should try to show that AP larger than or equal to AI. So how can we find the circumcircle of the quadrilateral BCIP? That means we should find the circumcenter of the circle, no, of the triangle BPC. So since I and BIC, of course, but I is the incenter of the triangle. So as we know, it is very easy to know that the circumcenter of triangle BIC is the intersection of the circumcircle of triangle BAC and ray AI. Let's draw it. So we draw a circumcircle like this, and then move it here, and then we draw the ray AI. If it's here, it will extend AI that intersect the circumcircle at point Q. So Q is the circum of the quadra. No. Concyclic quadrilateral BCIP. That's obvious. So we can know that what can we have? Since Q is the circumcenter, we can know that QB equals to QP equals to QI equals to QC. So we connect these points. Here. Let's draw it like this. So QP equals to QI. Let's copy the graph here to here. Since QP equals to QI, then we have we want to prove that P equals to point P equals to point I, or it is not equal, it doesn't equal to point I. So there's one thing that we need to be careful with, is that APQ might be collinear. So APQ might not be a triangle. So we have the inequality AP plus PQ larger than or equal to AQ. Since they might be, APQ might be collinear, right? And then what does it equal to mean? It means AP plus PQ larger than or equal to AI plus PQ, right? So we have AI plus PI, QI. So since we know that QP equals to QI, so we can have AP larger than or equal to AI. That's the first step. And when the equality holds. We know that A, P, Q are collinear. So it show we have P is the intersection of AQ and the circle of BPIC quadrilateral. Since AIP are also collinear, plus I is also on the circumcircle of BPIC, so from this we can know that P equals to I. Is it? So we have proved this problem. So that's the end of this question. Thank you for watching.